presentation is focused on Chapter 9 content from the book, which is on water quality. Water quality is one of the most important components that we'll focus on this semester. It's an area that I've studied a lot, and I'm excited to talk to you about it. The learning objectives for this chapter and this module are for you to be able to describe the various sources of water that is for drinking or potable water, define what's meant by the hydrological cycle, list hazardous substances that may be found in drinking water, how water is treated to be safe for human consumption, and then hazards for the aquatic environment associated with pollution. While we can live for months or days without food, we can only survive very little time without water. Average people consume more than 2 liters a day, and about 2/3 of our body is made up of. The average person uses about 100 gallons of water per day. This includes drinking, showering, for cooking, and all the domestic uses, flushing the toilet, water for laundry, and then even using it for watering our yards and lawns and washing cars. This is a lot of water, but with the installation of water efficient toilets and other devices, we've reduced our water consumption per person. This shows a figure of what we spend most of our water on. As I mentioned, very little of it is for drinking, flushing toilets, taking showers, and then landscape. Throughout the presentation, I will provide a series of definitions. Source water is water that's untreated, used to produce drinking water. Source water is in the city of Atlanta, it's the Chattahoochee River. Depending on where you live, your source of water will likely be a surface water or an underground water source like an aquifer. Finished water is water that's passed through the distribution system and arrives to your home. It may have gone through various types of drinking water treatment. As I mentioned earlier, surface water is surface water that's on the surface of the earth, such as lakes, rivers, ponds, oceans. And this is different from subsurface or groundwater, water that resides below the surface of the earth. Surface water is much more susceptible to contamination from runoff than groundwater. Although, if you remember back to the contamination that we discussed at Camp Lejeune, that was a groundwater contamination. These pictures show you examples of surface water. Some of these are reservoirs or dams that were created specifically for drinking water. The other picture that you see here is a natural body of water. Groundwater is contained in the pores in the sand or earth below the surface of the earth. In very arid areas or desert-like areas, groundwater is the main source of drinking water. In the western United States, many people use groundwater, although not all. It's less common to use groundwater in certain parts of the U.S. because of the high number of surface water sources we have available. Sometimes groundwater is influenced by surface water. That's because some surface water can get into the groundwater without having to pass through the earth and get filtered. And that can cause things like saline or salt concentrations to increase, or even allow microorganisms that would typically be filtered out as they pass through the earth to get into these sources. As I mentioned before, an aquifer is a layer or section of earth that contains fresh water known as groundwater. It's got pores, it's fluid, it's like a little body of water below the surface of the earth. Lakes are located at many high altitudes, and in arid regions they can become salty. The Great Salt Lake is one good example, and that's located in Utah. Glaciers and ice caps cover a large portion of the Earth's surface. They're concentrated in the northern countries of the world, Greenland, Antarctica. and they contain a large amount of fresh water. And one of the major concerns we see with climate change is that these glaciers start to melt, and it shifts how our water cycle is going to function. The hydrological cycle, or our water cycle, is the cycle by which water evaporates, accumulates in the clouds, and returns to other bodies as precipitation, either rain or snow. Water in aquifers and other resources that's not recharged or filled back up by the hydrologic cycle is non-renewable water. The reason that this can't be recharged is that significant withdrawal, typically for human uses, causes rapid depletion. Aquifers can often be in this category. It takes a very long time for water to seep back down into aquifers. If we withdraw water too fast, it can dry out the aquifer. Renewable water is continuously refilled or replenished by the cycle of the hydrological cycle and within reasonable time limits. This is for rivers, lakes, and reservoirs that fill up from precipitation or runoff. And as you've seen lately, we've had a lot of rain in Atlanta. The rivers are full, they're flooding neighborhoods. Lake Lanier is full. Lake Lanier is a major source of water for some of the counties north of the city of Atlanta. And it's causing flooding because there's so much water, which is both good and bad. Artificial lakes, like Lake Lanier, produced by constructing physical barriers, allow water to pool and be used for lots of purposes. This is a very common practice. We use it both for source water or drinking water sources to collect them, capture them, store them, use them for drinking water. We also use it for recreation, to create energy, for hydroelectric power, where water flows through a turbine and generates energy. So we use this reservoir for a lot of different things. Runoff is when water originates as rain or snow on land and then runs off into these open bodies of water, rivers, streams, lakes, eventually reaching aquifers or oceans. When we remove water from any source, that water can be returned to the environment if not consumed, and it can be used again. But typically what happens is we remove water, we consume it, we excrete it out in our sewage, in our showers, we use that. It has to then be treated and returned back to the bodies of water. We may not recover all of it that way. Now I'm going to go through a couple of important definitions regarding water and water access. Water scarcity is when the annual supply of renewable fresh water is less than 1,000 cubic meters per person. Countries can experience chronic and widespread shortages that hinder their development. It will reduce agricultural, economic productivity. It may create civil unrest. Water stress is when annual supply is between 1,000 and 1,700. And these countries that experience water stress can expect to experience temporary or limited water shortages, not nearly as severe as water scarcity. Wetlands include swamps, bogs, marshes, lagoons, and floodplains. Sometimes these are entirely made up of freshwater or river, or sometimes they're also with saline water, salt water as well. These are very important ecologic resources, but sometimes they also contribute to concerns for the environment. They can enable development of vector-borne diseases transmitted through mosquitoes, but in the past we have used these and realized their importance and stopped trying to destroy these ecosystems. The Amazon River is a great example of one of the largest wetlands in the world. The Hudson Bay is another, and there are lots of different wetlands in the Great Plains of North America. Although the Earth's surface is covered mostly by water, almost all of it is not usable for drinking or most purposes. 3% of all water is fresh water, which is what we could use for consumption. and a lot of it's unavailable because it's in ice caps and glaciers. About 1% of all water is accessible via surface, freshwater, lakes, rivers, or underground aquifers. There are many regions of the world that face water scarcity, and we know that this is going to increase and shift during periods of climate change, but the ones most commonly known for this is Sub-Saharan Africa and North Africa. And there are also some other places in Asia and the East. In the United States, water supplied to the public has to go through water treatment processes that meet the Environmental Protection Agency's chemical and microbiological contaminant requirements. These are called maximum contaminant levels. They're under the Safe Drinking Water Act, and they ensure that the water should be free of chemical and microbiologic contamination that would cause harm to the population. We actually add a chemical to the water. Many communities, almost all, add fluoride. This is to enable protection of your teeth and prevent tooth decay. And it's been heralded as a major advance in the reduction of cavities. These are the main steps in a water treatment plant. First, any material that's solid, like particles from the river, gets brought together through chemical coagulation, where these particles, we add a chemical to the water that allows them to attract to one another and become bigger. They will then settle out through sedimentation, where now that these particles have attracted to one another, they become big enough that gravity allows them to settle out. We then often pass the water through a filter, which removes smaller particles, ones that didn't settle out. And then we add a chemical disinfectant or a physical disinfectant like UV. This kills bacteria. It may kill different viruses. Some disinfectant processes can kill pathogens such as protozoan pathogens, and then the water gets sent to your home. This picture is an example of water treatment basins in a water treatment plant. You can see these would be secondary processing, like maybe sedimentation. When we have groundwater, which has already gone through its own filtration process, many times we don't have to do all of the stages of treatment that we do for a surface water. Groundwater can often be free from larger microorganisms because they've been filtered out, and so typically we do fewer activities when we're using groundwater. Contaminants that can occur in groundwater, though, are chemicals and nutrients like fertilizers and nitrates from agricultural lands. We still may see heavy metals and sodium, and organic chemicals from leaking underground storage tanks. Groundwater is particularly susceptible to contamination that will leak from tanks that are stored in the ground. And those are the type of situations we find high levels of chemical contamination, which happened in, for example, our study that we talked about in the first period of class about Camp Lejeune. Other contaminants we might be concerned about finding in waters, both ground and surface, chemicals used in the home, heavy metals, and some microbial pathogens. These can happen and get into the water for a lot of different reasons, and we'll learn a little bit more about that in a minute. Diseases to be concerned about that are associated with consuming contaminated water are called waterborne diseases. These diseases are transmitted through the ingestion of water. Water acts as a carrier of this agent. Some good examples are cholera. You may have heard about this disease. It's not very prominent in the US, but in other countries it causes a very large burden when it's present. Cryptosporidium, which causes cryptosporidiosis. This is an illness that causes diarrhea, abdominal pain, and typically resolves on its own, but can be serious if you're immunocompromised. It's our biggest challenge for surface waters for drinking, as well as for recreational water like pools, because Cryptosporidium is very resistant to chlorination. We also are concerned about viruses that may get into the water and don't adequately get filtered out through either because we're using groundwater or aren't treated well in our systems. But those are easier to treat with disinfection than crypto. We have bacterial pathogens and other agents that can cause illness and have been the source of outbreaks. Some chemicals that have been reported to cause adverse health effects and be in the water supply, of course, lead we know a lot about. We've been learning about that. Some pesticides. Arsenic is a metal that we're concerned about as well. And unfortunately, arsenic can be naturally found in the water. And if we don't test it, especially our groundwater sources, depending on the region of the world, we could be unknowingly exposing ourselves to arsenic, which is known to cause cancer. What are the challenges and health effects we may see because of chemicals in the water supply? We're very concerned about long-term exposure resulting in different types of cancers. We could see potential adverse reproductive health outcomes, difficulty during carrying when women are pregnant. We could also see cardiovascular or neurological disease associated with chemicals in the water supply. Some may suggest, as one of the students' papers, that exposure to, for example, different pesticides, both because they were applied nearby the home but also got into the groundwater, may cause things like Parkinson's disease. Interestingly, we're seeing growing concern about personal care products and pharmaceutical materials getting into our water supply. These come out into the sewage from our bodies, or people throw away their old medicine in the landfill and then these chemicals are washed into the surface waters. We often can detect these in the sewage and we don't do a wonderful job of removing them. People that have various illnesses that are very common often consume these drugs every day, and the body doesn't always use all of them, and so we can find these readily in sewage. One important contaminant that is created by us treating water and disinfecting it to reduce the risk of infectious diseases is called disinfection byproducts. Disinfection byproducts are the result of treating water with chlorine or other disinfectants. It produces a new chemical, and these are called disinfection byproducts. They exist in various states, and we can do our best to control their formation in the water, but it still happens. And there is some concern about adverse health effects because you consume water for your entire life and you may be experiencing low level of exposure for 70, 80 years. Some disinfection byproducts have been examined to see if they are associated with adverse pregnancy outcomes, such as birth defects, other anomalies. But we don't know a lot about that, and it's very, very hard to study that relationship. When we think about other environments, of course, coasts are where the majority of the world's population lives, and this causes a lot of stress on coastal ecosystems. They're threatened by overdevelopment, poor planning, and many of the world's regions of coastal areas receive untreated sewage. Even in the United States, we used to just pipe our sewage very far away from the beach, but we didn't treat it. And that's the case with a lot of other countries in the world. What can pollution do in these environments? It can cause blooms of algae, resulting in reduced levels of oxygen, and that can result in killing the fish and other forms of sea life. We can also see that runoff and sewage contamination can make swimmers in these settings exposed to waterborne diseases. Of course, there was a major oil spill near the shoreline in 2010. It's the largest marine oil spill in history, and we know that it has devastating impacts on aquatic life, mammals, and birds.